Hello, students. So I want to do one more video. This is going to be about two-dimensional collisions. And, well, effectively doing things in multiple dimensions. And the idea here is that your momentum is just mass times velocity, but they're vectors. And the vectors have components. And so the x component is just the mass times the x component of the velocity, and the same thing for the y component. So whenever we make a statement about doing a collision in two dimensions, we have to keep track that we're talking about motion with components, with vectors with components, and we have to deal with that. So let's do an example. We're going to look at a car, 1,000 kilograms, going at 8 meters a second through a red light. And another car, which will be down here, is 600 kilograms, going through at, that's a good number, 5 meters a second. Right? And so they're going to collide. And we're going to say that at the collision, they're going to stick together. Their bumpers are going to lock and they're going to slide together. And so the wreckage is going to slide off like that. There's some angle theta that we'd like to know, and we'd like to know the velocity at the moment of collision of the wreckage. Now, obviously, what will happen is, cars will drive along and they'll go, and then they'll crash. And then the drivers are hopefully sensible enough to put the brakes on. They're not going to they're not going to continue on like this. Now, one thing we can do is note that the center of mass idea holds on this. So in purple, I can draw the center of mass, and right now it's there. And it's going to move along this dotted line, and then it's going to move along the velocity vector. So we can find the velocity of the center of mass if we want to. That is the total momentum over the total mass. Now this is where we have to be careful, is these things are vectors. This is 8 meters per second in the I direction, or in the x-axis direction. And this is 5 meters per second in the j direction. So the total momentum, well, that's just going to be adding up these things. Here the momentum, we'll call this one 1 and this one 2. So momentum 1 is going to be, m times v is 8,000 kilogram meter per second I hat. And so here P2 is going to be, 600 times 5 is 3,000 meter per second j hat. And so the velocity for the center of mass is going to be 8,000 kilogram meter per second I hat plus 3,000 kilogram meter per second j hat. And we divide by the total mass is 1,000 plus 600 is 1,600 kilograms. And so this is going to be 5 meter per second I hat plus, and then this is going to be not quite 2. 1.875 meters per second j hat. And then in a collision, that's the final velocity. Now, if I wanted to do this, properly, I could go through and say, well, this is my momentum. Then my final momentum must be the sum of this. So 8,000 I hat plus 3,000 j hat kilogram meter per second. And then I'd find V final is P final over M total. And that's just what I did here. So if we want to find the angle, this vector has components. Theta here is going to be inverse tangent of y over x is 1.875 over 5. And we figure that out. That'll be 20.5 degrees. And then this size of V final is going to be finding based on Pythagorean theorem from this. So it's going to be 5 squared plus 1.875 squared. And take square is 5.34 meters per second. Now we can check, does this make sense? 5.34 meters per second times our total mass, 1600, and we get something like 8,544. Now note that that is not 8,000 plus 3,000, right? But what you have to do is go and take these numbers and do Pythagorean theorem to get whatever the length of this vector is. Right? So if we did that, 8,000 squared plus 3,000 equals square root, you get the same thing. So this is the important bit. These things are independent. They don't mix. You can't mix the x stuff and the y stuff up. It means you have to solve those problems independently. So let's do another problem. So one of your homework problems has that you're going to use billiard balls. So, if you pay attention to what's going on here, you learn how to shoot pool. And when we talk about collisions, what I'm going to use is a little sliding disc, and we'll say that this is 0.1 kilogram, and we'll let it go along this way at 4 meters per second. It's going to hit another one here, but it's going to be a glancing blow. So what happens is this one slides off at an angle. We'll make this 30 degrees, and it will be 2 meters per second, and we'll make this one 0.15 kilograms. And then we want to know where this one goes. It's going to go somewhere up this way with some angle, which I'll call phi. There. So we'll call this one 1, and this one is 1, and this one is 2. So this is 2. So we want to know how these things are going to bounce off of each other. Now, if these were equal, then there is a nice rule, is that these two angles add up to 90, but they're not equal. And so we're going to have to work out how do we get this. Well, what we're going to do is put our axes plus x and plus y. And so we note that when we start out, this thing is at rest, and this thing is moving, and everything is in the I direction. It's going along the x-axis. So we can go through and say, well, the total momentum in the x direction is something, but the total momentum in the y direction is 0. Because there's no part of this thing moving in the y direction at the beginning. So in the x direction, we have m1 v1 vector plus m2 v2 vector. Well, this is 0.1 kilograms times 4 meters per second. This is 0.4 kilogram meter per second in the I direction. So we have to have this after, so this is initial. We have to have this Right? The x direction part is this, and the y direction part is this. We have to have that in the final condition. So in the final, sum of the momentum in the x direction is going to be mass 1 v1 x final plus mass 2 v2 x final. Well, those things are components. You can draw in both of those components here. This one will be mass 1 v1 final cosine phi, and this one will be mass 2 v2 final cosine theta. And this whole thing has to be 0.4 kilogram meter per second. And we do the same thing with y. The y components have to be m1 v1 y final plus m2 v2 y final. And those are these components, the up and down components. So vy, vy, vx. And so these have to be mass 1 v1 final sine phi plus m2 v2 final cosine, sine theta. And this has to be 0. So what this does, it gives you a system of equations, this one and this one, to solve for. And what's nice is that we already know numbers that go into these. Right? So let's see, let's plug some stuff in. M1 V1 final cosine theta is doing purple. Actually, since we don't know that, we have to get this one. So it'll be 0.15 kilograms times 2 meters per second times cosine 30 degrees. And this one will be 0.15 kilograms times 2 meters per second times sine of 30 degrees. And so this term is 0.15 kilogram meter per second. And then this term is 0.15 times 2 times 30 cosine is 0.26 kilogram meter per second. So that means, all right, we have 0.4 and 0.26. This whole thing has to be 0.14 kilogram meter per second. And this thing has to be minus 0.15 kilogram meter per second. And that's going to let us get, essentially we can cancel out parts of this. We can figure out what the angle is by dividing these two. All right, so we're going to divide this by this. And so we'll have 0 on one side. And on the other side, we'll have, well, the mass 1's cancel, and the V1 finals cancel, and we'll get tangent theta. Did we do something wrong? Yeah, ignore that. Ignore what I just said there. We're going to take and look at these two terms. All right, 0.14 kilogram meter per second is M1 V1 final cosine phi, and minus 0.15 kilogram meter per second is M1 V1 final sine phi. So if we divide these, this side, we're going to divide this one into this one. Sorry, we're going to get tan theta, and on this side we get minus 1 point something, 1.07. And so we'll get out of this at phi here. So we'll get out of this that phi is doing the inverse tangent of this. Inverse tangent is 46.97 degrees. So we know where this goes. Now we can take this bit and say what these numbers end up having to be. Okay. 0.14 kilogram meter per second equals 0.1 kilograms times V1 final times cosine of 46.97. And we get V1 final is, let's see, take the cosine of that. In memory, 0.14 divided by 0.1 divided by the memory bit, we get 2.05 meters per second. That kind of makes sense. We start out with this thing, it's going 4 meters a second, and then it bounces off. Most of the momentum should go with the heavier object. Sorry, it bounces off of a slightly heavier object, so the heavier object goes a little slower, and the lighter object goes a little faster. Roughly what we suspect. Okay, that seems okay to me. But that's the gist, is it's a laying out of the problem. And the solutions here really are in these green boxed areas. It's coming up with the way of stating what's going on. So for most of this stuff, it's not going to be that bad, right? Number 8 is kind of the simplest sort of problem, is this sort of thing. You know, instead of cars, it's football players. Number 9 is going to be a simpler version of this. The masses are the same, and you're given these angles, and you can figure out stuff. 10 is talking about center of mass in 2 dimensions and total momentum in 2 dimensions. That is doing this sort of thing. 11 is one-dimensional and 12 is one-dimensional. So there's not a whole lot of 2-dimensional stuff. This should be okay. So if you've got questions, I want you all to email me with those questions. But otherwise, I think, given that you've had a week to look at it and then you're seeing the videos, hopefully some of this makes a little more sense. I mean, I know it's a lot of stuff. This is one of the harder sections because there's so much algebra in it. One of the more tedious sections, but it will be all right. So email me. Let me know if you got questions, okay?